Hello guys and namaste, welcome to my channel. So today we are going to work on a simple game, tic-tac-toe. So we are going to work on this new game as a beginner. So we are going to keep everything simple so that a beginner can also understand. Before we actually move on to the project, if you are new to my channel, if you haven't clicked that red colored subscribe button, please do right now, because if you are not doing that, then you are going to miss a lot of videos that I regularly post. So do that and let's kickstart this video. Alright, so we all understand the simple game, what is tic-tac-toe, so I don't think I have to explain what this game is. So in this game what we have to do, we have to create a board. This board is basically going to have 3 rows and 3 columns. And then we are going to have 9 cells. So these will be your cells, right? Now we have 9 cells that we need to build. So that's the first thing. Now we need a player who is going to play with AI. So we need an AI. So player is going to be the user, and you are going to be asked for the user prompt and then provide where you want to place your move. Now for AI we are going to use an algorithm which is going to be Minimax algorithm. So this algorithm will recursively checks all possible moves and will choose the one with the best outcome for the AI. So the game flow is going to be like, it is going to continue till there is a winner or the board is filled. So if you win, then the game is complete, or if the board is full. Alright, now let's understand the code logic that we have to do with this program. Alright, so the very first thing that we talked about was board. So that is going to be the very first thing that we will do with the program. So here for board what we need is, we need a list, and this list is going to be having 9 spaces. So for which we will have spaces like this, and then we will have a for loop for the repetition. So here we will say in range 9. Alright, that's very simple. So this is going to create a 3 by 3 grid. Initially all the cells will be empty, what we have done here. Alright, and then the second thing is printing the board. So here what do we need is, we have this list with us, so we will initialize it with board, and then we will simply have to print it. So it will look something like this for row in, and then your board I multiply by 3, then the index which is I plus 1 3, then your list is going to complete. Then for I in range 3, because it's a 3 by 3 grid, right? I know it's a big for loop, but just hold your horses. Then we will print this pipe and again this pipe, and then we will join this with row and then pipe again. This code logic is basically going to print the current state. Remember that what is happening, that we are not going to print, we are going to print whatever has already happened, right? Now this board is divided. So here what we have done is, we are dividing the board into 3 rows. Alright, then each with 3 elements and formatting it into a grid using join. So here we have created a grid, and this grid is basically going to have horizontal separators which we have as pipe. Now then you have to check if there is a winner or not, because with every move you have to check it, right? So we will have win conditions here, which we will allocate in a list. So that I won't be able to type here, but yeah, this is going to be your win conditions, and we will iterate this win condition. We will check whether the player has already won or not. If yes, then we will return true, otherwise return false. So this will be a function which we will create. So here what we are going to check is, we will check if the player X or 0 has won by comparing the player's mark on the board to all the possible winning conditions, horizontal, vertical and diagonal lines, right? So the conditions will include your horizontal, vertical and diagonal lines. Now there will be one more method which will check whether the board is already full. So here we will simply check that the space should not be in board. If it is true, then we will just print that the board is full, right? And then we have the min-max algorithm for AI. So here with the min-max, what is the objective? The objective is to maximize the chances of winning while minimizing the player chances of winning X. So this is what this min-max do. So the best case scenario here would be that AI wins. If the AI wins, in that case return 1, which is good for AI. Then if the player wins, return -1, which is really bad for AI. If the board is full and no one has won, so return 0. These are base cases that we have to put in our program, right? Now, like I said before, this is going to have a recursion. So in recursion what we are going to have, we are going to have AI play optimally by choosing the move that maximize the chances of winning, and for each move the min-max, that function that you have, so this will be recursively called to explore future outcomes. Now this is your first set. In your second set, what we have to do is, we will check with a boolean variable whether this is true or not. So if it is true, it means that the AI is trying to maximize its score, so it chooses the move that gives the best possible outcome for itself. Now there is another outcome that is maximizing, could be false, so it simulates that the player's move trying to minimize the AI's chance of winning, so it picks the worst outcome for AI. Now I won't be able to explain the AI algorithm here, but we'll see in the. Alright, so now let's work on the code. We have already talked about much, but let's work on the code and let's understand it better. Alright, so now let's create a new Python file. So let's name this tictactoe, and the very first thing is that we need math library. I'll explain why do we need this. Now, like I said before, first thing is that we have to initialize the board, and for this we are going to have spaces, and then we will do in range 9. Now we will simply print this board. So again a method, we will go in the same order, and here we will have to divide the board into 3 segments, as in 3 rows. So here I is going to be your iteration, I, then 3, and then I plus 1, and then 3. Then we will have the another iteration for I in range then 3. In that case we will print Alright, now let's understand, and let's run this method. print board. I know I made a typo there, so let's change this and let's run this. Alright, so let's run current file. So here you got this. So here if you see, this is your first space, this is your second space, and this is your third space. Similarly you have everything. Alright, now I know that this is going to be difficult to understand, so let's simplify this a bit. So the another alternate is that like I said, we have to divide the grid into 3 segments, as in 3 rows. So in that case we will use for I in range, so 0 to 9, that's your grid, and then you need it to be divided in 3 parts, right? So here, instead of slicing the list, we used a simple loop to access each row by directly indexing into the list. So this loop iterates in step of 3, printing each row of 3 elements, right? So to print that, we will use a formatting something like this. So here we need pipe for segregation, and then we will provide the index of that list, so that is going to be I. And then what we will do is we will repeat this, but we will have to increase the I counter, right? So something like this, I plus 1, and similarly I plus 2. Afterwards we will have another pipe for ending. So the major part is this, that you have space, pipe, space, pipe, space, and then you have this for the end of the line. Alright, now let's run this. Let's see if everything is working fine. So you have, yes, you have everything working fine. Alright, so here if you see more spaces, that's because we have added more spaces, right? So that's okay, it looks good. Now let's move back. Now we need the method to decide whether there is a winner or not. So we will create a function here is winner, and here we need the move. So here we need to check if the current player has won or not. So for that, like I said before, we need conditions. So these conditions are going to be the best possible outcome that we are going to iterate over and see if that is true for the current player or not. So for horizontal, to make the player win, it should be like 0, 1, 2. If these 3 are filled, then the player has won. Then we have 3, 4, 5, which is this. Then we have 6, 7, 8. So these are the horizontal conditions. Then we have vertical 0, 3, 6, and then this, and then this. Then we have diagonal, which are going to be only 2 conditions, 0, 4, and this one is 8. Then this is your what is this, 2, and then 4, and this is 6, right? So these are the conditions that we have to make. So first we are going to go with horizontal. So this is going to be 0, 1, 2, and then you have what is this, 3, 4, 5, and then lastly you have 6, 7, 8. Alright, so this is your first horizontal condition. Then you have vertical condition, which is going to be 0, 3, and 6, and then you have 1, 4, 7. Similarly you have the last row column, which is 2, 5, 8. Diagonal, there are only 2 conditions, so 0, 4, 8, and then 2, 4, and then 6. Alright, so these are your win conditions. Now we need to iterate over to see if any of them satisfy the requirements. So we will iterate over win condition, and we will check if board, the current board with the condition, current condition is equals board with the condition 1, and then it should be equal board condition 2, and then it should be equal to the current player. If that's true, then return true, otherwise return false. So here we are first iterating over our win conditions, which we did. So purpose is to loop through each possible winning combination, right? So these are your winning combinations, and check if the current player has achieved any of them. So if amongst these three, if the player has any one of the possible scenario, then he has already won, right? So here we have three conditions: condition 1, 0, 1, 2, which is your this scenario. So there are three indices in the current winning combinations. So talking about this condition, the value in the board at the first index of the winning condition. So this is going to check that. So this is the first index. Then the value of the board in the second index, and then the third index. So it will check if that is true or not. So if it is equal to the player, so it will check if all three positions contain the current player's symbol. So it could be either X, it could be either O. So here we check this. If it is true, then we will return true, otherwise false. Alright, so now if you are getting confused that we have a simple one-liner condition check. So this is a equality check, and the operator is chained to simultaneously check if all three specified positions on the board are equal to the player symbol. So this is one of the way to do it. Otherwise you could have divide it into three parts, as in if board condition 0 equals player, and board condition 1 equals player, and with board 2, right, which we didn't want to do. So this is the very simple way. Now let's take an example to understand this. So let me open whiteboard again, drag it to top, and let's understand. Let's say that in the current board state we have scenario something like this, that we have X, then X, then X, and then you have 0, 0 and blank here, and then nothing down below. So in this, the board list is going to be something like this: X, comma X, comma X, O, O, then blank, then blank. How many blanks are there? 4, right? So 4 blanks. Now this is your board list. So the first condition is your 0, 1, 2 index. So here the board of value 0 is this, then board of value 1 is this, and then board of value 2 is this. So in our win conditions we had three set, right? So we had horizontal, we had vertical, and then we had diagonal. So in horizontal we were checking like this, right, and in vertical we were checking like this, and in diagonal we were checking like this. So we were iterating from horizontal first. So these are your win conditions 0, 1, 2 for the very first iteration, and we got the condition satisfied. So in that case we will return true, and we will say that the player has won, right? So this is how you check for the win conditions. Now let's come back to code again. Alright, now we have checked for the winner. Now let's check if the board is already full or not. So we will have a method again is board full, and simple as that. We will just check there has to be spaces. So here we will check if there is space, then that means that the board is not full, otherwise board is full. That's it, simple as that. Now we are having a min-max algorithm with AI, so let's work on that. So this is the core logic with our program, right? So min, minimax, and here we will have a boolean variable is maximizing. Now we will have some conditions to break this recursion, because we are going to have recursion here. So the very first condition is going to be if there is a winner already, then get out from the loop. So the winner can be through your O, or can be through your X. So O is here, X is here. Alright, so if we say 1, in that case your player wins. If it is -1, in that case AI wins. Alright, now there is going to be an else if condition here also. This is going to be else if the board is full. That's the third condition. Is board full? In that case return 0, then this is going to be a tie. Alright, now the main thing, which is going to vary depending on if is maximizing is true or not. So if is here, then else is. So if it is true, in that case we will have a best score, and that is where you need math. So we will do -infinity here, math dot infinity, and then we will iterate over the range as in your entire grid, because we have to find the maximum possible outcome here. So here if we will check for the existing values, so if board of the current instance is empty, that is where you have to place the move. So in that case we will do board I, and a computer's move, AI move, is going to be O. Alright, then you need to calculate the score. So score is going to be using again your recursion. So here we will provide false. Don't worry about it much if you don't understand it right now, I'll explain later. And then I will do empty, and then we'll calculate the best score with the max, and here I'll say score and then best score. Alright, and then at the end of the execution we will return best score. This is our if condition. Now for else condition we are going to have roughly everything same. Let's copy this. The only difference is that here we will have positive infinity, and instead of 0 we will O, instead of O we will going to have X, and here we will not return, here we will not provide false, rather true, and instead of max we will do min. So the complete opposite. So this is your min max method. Now let's understand this logic in detail. So the min max function, as I told you, is the core of the AI in this game, and it enables the AI to make optimal decisions by evaluating all possible moves and selecting the one that maximizes its chance of winning. Right, now let's understand the objective, and we have already talked about this before. So the min max algorithm is a recursive function used in decision making and game theory to determine the optimal move for a player, assuming that the opponent also plays optimally. So in this case we are going to have a maximizing player and a minimizing player. So if it is a maximizing player, then the AI O aims to maximize the score. If it is a minimizing player, in that case human player X aims to minimize the score, right? So scores we have already talked about. If it is a positive one, then player wins. So if it is returning 1, then in that case the AI has won. If it is returning -1, then the player has won, otherwise 0 as tie. Now the major thing is this if condition, right? So here what we did is, first is we need this best score, right? This is what we are returning here. So it could be 1, it could be -1, it could be 0. Now here we are returning the best score. So this is the major thing that we have to initialize first. So we are initializing this with -infinity to ensure that any actual score will be higher. That's why we are using -infinity. Now we are iterating over all the cells. Then we are going to loop through each cell on the board, right? Now we will check if the cell is empty or not. So that is why we have this condition. So if the cell is empty, it means that a move can be made here. Now here we are simulating the move. So we are going to assign O to the empty cell. That is what we did. Then we will call min-max false to simulate the player's move next, right? So here we are minimizing the player. Then the function returns a score based on the outcome of this simulated move. So that is why you have best score here. Now we will have a recursion here. So we will do undo move, which is your backtracking. So here we will reset the cell to empty. So here we will reset this board to empty or cell to empty. Then this major step is very crucial to explore other possible moves without affecting the actual game state, right? So this is what we did, backtracing this one. Now we have to update the best score. So we will compare the score with the current best score. We will update the best score only with the maximum of 2. So whatever is maximum, that we are going to keep here. Then we are going to return the best score. So after evaluating all possible moves, we will return the highest score achieved by the AI. Alright, now talking about minimizing player's turn. So here we have initialized the best score with the positive infinity to ensure that any actual score will be lower. Then we again iterated over each cell. Then we checked if the cell is empty or not. If the cell is empty, then we mean that a move can be made here, right? Similar to what we have done in maximizing. Now we have to simulate the move. So here first thing is that we are doing an X there in the existing cell where we have empty. Then we are calling the min-max method to simulate the AI's move next, as in maximizing player. The function returns a score based on the outcome of this simulated move, right? That is why, so that is how you get the score. Then we will reset everything to empty, and then you get the best score by calculating the minimum of these two scores. Now how this method works overall. So this minimax function evaluates every possible game state resulting from the current board state. So first we have recursive exploration, where we actually explore all possible moves for both AI and the player, and each recursive call alternates between minimizing and maximizing strategies. Now we have scoring outcomes, which is basically +1, -1, 0, and then you have optimal move selection, which we are doing with this best score. So AI selects the move that maximizes its minimum possible loss, ensuring the best outcome against an optimal opponent. Now, like I said before, we have to check for the best move. So when we are done with Minimax, then we will do best move to choose amongst the possible scenarios. So here we will have best score and math.infinity, -infinity. Then move will be initialized with 0 index. Then we will have a for loop on the entire grid. And then we will check if there is any empty space there or not. So board I equals empty. In that case, initialize this with O. Now we will calculate the score using Minimax, and here we will provide false, and then we will empty the board again, as in the particular cell, not the entire board. Then we will check if score is greater than the best score or not. That is what we wanted to do. So if it is true, in that case we will do best score equals to score, and the possible move is going to be now I. That is the index that we want. So we will check for the maximum possible outcome using Minimax here, right? And then we will run move. That's it. Now this was your AI move. Now you have your player move. So player move is going to be very simple. So here we will ask for the input from the user. So we will say enter move between 1 to 9, and we will do -1 because we have to start from 0. Then we will check the move on the board. So if it is empty, in that case we will say yeah, move is placed. Otherwise we can say invalid move, and then we will call the same method again recursively. Alright, now we need a main method. Now we have our main execution, so we'll print welcome to tictactoe. You are X and AI is O. Alright, then we will call print board to initialize the board, and then we will have our while loop. So this will go on and on until someone has won. So we will only break if there is a winner. So we will check if winner, and here we will first check for AI. In that case we will print AI wins, and then we will break. Else if is board full, so we will print it's a tie, and then we will break. Alright, or you can keep go on and on until there is a winner, right? You can have that option to not break this. Now first thing first, in your while loop is going to be your player move, and then there will be board reflected back with the move. Then we will check if there is winner already, and this is for your player, not AI. In that case we will print you win, and then we will break. Else if there is condition for your tie. Alright, now talking about AI move. So AI move is coming from your best move, and then you have to initialize board with that move and do O here, and then we print the board again. Print board method, and we are done. Now let's run this and see if everything is working fine. So welcome to tic-tac-toe, you are X and AI is O. Enter move between 1 to 9. So I'll do 9 here. Oh, it failed already. List indexes must be integers or slices, not list. So the mistake was this. Alright, let's run this. Welcome to tic-tac-toe, 9 again. Oh, that's not good. So here we got the player's move and then the AI move, and in the player's move it didn't actually print the X, but for AI it did work. So let's fix this. So for AI move, first thing is that we should have a counter so that the program can sleep after printing something like this. AI is making a move, and then we have to wait for a few seconds. So let's import time here. And where did it go? Okay, here we will do time dot sleep, and here we have to provide seconds, so let's do 5. So if I run this, I know that the player move is not working, but let's see if this one is. Let's do 8. Okay, so here it did do X here, and it's waiting right now if you see, and then we got this. Alright, so it's working, but why didn't it work on 9? That's the main question. So okay, on 9 it's breaking. Okay, that's not good. Okay, here I have 0, so let's update this with O. Now let's update print board method as well. So here I have 2 instead of I plus 2. Alright, looks good. Now let's run this again. Let's see, 9, and yeah, we got X. AI is making a move. I think 5 seconds is a lot of time, but okay. Now I can move, let's say 1, 2, 3, 4, 5, 6. Okay, now I will do 1, 2, 3, 4, 5, 6, 7. Okay, now I have to place here, otherwise I will lose. So 2, and there is not going to be any winner now. So I have only one option, which is your 4. So 4, and it's a tie. So it's working fine, right? I know that it's going to be difficult to win this, but yeah, this game is pretty much working fine. Now the problem that I got with move is because of this print statement, but also you can have some validations. So validations you can do here when you're asking for the input. So here what you can do is here, let's say if move less than 0 or move greater than 8, because we have already done -1, in that case we will print invalid input or move, invalid move. Else if board move not equals to space, in that case we will say, let's say invalid move again, or you can say cell is already occupied, whatever works for you. Now we just need else condition, so let's remove this, place it here, and okay, let's do a while loop also. While true, and here we will break. Alright, so let's run this, let's see. So here I will provide -3, -2, and it will say invalid move, let's say 10, invalid move. If I provide correct one, let's say 1, then it will work fine. Alright, so this is what I wanted to showcase in this video. I hope there is no questions as of now. If there is, then do let me know on the comment section, and if you have anything specific that you want me to make a video on, also let me know. So this is it for this video. I'll put the code in some GitHub repository and provide the link on the description, so you can take a look there. And I really hope that we will meet in some other video. Till then, stay happy, keep learning, and bye bye.